The digital track circuit FTGS is a remote feed coded audio frequency track circuit from Siemens. It is designed for track detection system. Siemens abbreviations for different types of track circuits. ST equal to standard track circuit, straight track circuit. M equal to center feed track circuit. W equal to point track circuit. K equal to crossing track circuit. FTGS is available in two configurations: FTGS 46 low frequency, FTGS 917 high frequency. The main difference between the two configurations is the frequency range in which they operate. This system includes power supply unit. The transmitter consists code generator, modulator, power amplifier, transmitting filter, transmitting end cables, lightning protection, tuning unit at transmitting end, bonds on rail, tuning unit at receiving end cables. Receiver consists of two identical channels and it consists receiving filter, receiving amplifier, demodulator, and operation train detector relay. Main features FTGS. Minimum ballast resistance equal to 2 ohm per kilometer. Train shunt resistance equal to 0.5 ohm outside the tuning zone. Train shunt resistance equal to 0.15 ohm inside the tuning zone. Power consumption equal to 65 volt ampere to 90 volt ampere. Rail types equal to 90 pound, 52 kilogram, 60 kilogram. One transmitter can coupled with maximum 3 receivers. Remote feeding equal to 3 km, 0.9 mm diameter quad cable. Cables for feed in and feed out. Quad cable 0.9 mm diameter copper conductor as per specification IRS TC30/96. Modulation frequency shift keying. Bit pattern coding. 15 types. Transmission speed 200 bits per second. FTG S46. Operating frequencies F9 4750 Hz, F10 5250 Hz, F11 5750 Hz, F12 6250 Hz. Frequencies at gap of 500 Hz. Length of tuning zone equal to 14.8 meter with single cable. Length of tuning zone equal to 17 meter with multiple cable. Length of track circuit equal to 250 meter to 350 meter end feed. Length of track circuit is equal to 500 meter to 700 meter center feed. Power consumption standard configuration ST 80 VA approximately 32 watts, center feed in M90 VA approximately 40 watts. Remote feeding FTGS 46. Diameter of quad cable used 0.9 mm. For axle shunt value is greater than or equal to 1.0 ohm. Length of transmitter cable is 3 km. Length of receiver cable is 2.9 km. FTGS 917. Operating frequencies F1 9500 Hz, F2 10500 Hz, F3 11500 Hz, F4 12500 Hz, F5 13500 Hz, F6 14500 Hz, F7 15500 Hz, F8 16500 Hz. Frequencies at gap of 1000 Hz. Length of tuning zone equal to maximum 6 meter. Length of track circuit equal to 30 meter to 220 meter end feed. Power consumption standard configuration ST is 65 VA, approximately 26 watts. Point tracked W is 75 VA, approximately 30 watts. Center feed in M is 75 VA, approximately 30 watts. Crossing track K is 85 VA, approximately 38 watts. Remote feeding FTG S917. Diameter of quad cable used is 0.9 millimeter. For axial shunt, value is greater than or equal to 1.0 ohm. Length of transmitter cable is 1 kilometer. Length of receiver cable 1.5 kilometer. For the axial shunt, value greater than or equal to 0.5 ohm. Length of transmitter cable is 1.4 kilometer. Length of receiver cable is 1.5 kilometer. Transmitter board. On front panel of this card, following are provided: frequency window, code bit window, LED indications, L9, L1, L2, L3, L8. Note: no measuring sockets are provided on this card. Transmitter board consists frequency plug, coding plug, quartz oscillator, modulator. The transmitter card consists of a quartz oscillator with modulator. Here, the audio frequency voltages from 4.75 kHz to 16.5 kHz are generated and modulated with the bit pattern. Frequency plug selected determines the track circuit frequency required. In FTG S46, in FTG S917, another coding plug determines the bit pattern to be transmitted. Different bit pattern code plug numbers are as per this table. For these plugs, pins are provided on top side of card near front side. Track frequency generated is modulated by frequency shift keying, but according to bit pattern. LED L2, L3 indicates the shift keyed frequency according to its frequency position. LED L2 lights up for the upper frequency and LED L3 lights up for lower frequency. Resulted time division multiplex signals are feed to amplifier and filter circuit. LED L1 indicates voltage output of amplifier. An additional circuit is provided, that is generation of scanning pulse to evaluate receiver and demodulator signals. The clock frequency of 16,336 Hz is generated by dividing the frequency of the quartz oscillator. LED L8 green light indicates correct functioning of additional circuit. LED L9 green light indicates correct functioning of intercode short circuit supervision. The bit pattern is voltage dependent. If operating voltage falls below preset limit, the bit pattern is inverted. This is recognized by the demodulator, which then de-energizes the track relay via receiver to board. After recovery of voltage, a defined operating sequence in receiver 2 prevents the emission of track occupied signal as long as there is no fault in the installation. Filter and amplifier board for FTG S917. The filter and amplifier board raises the modulated audio frequency of the transmitter to the required level and then transmits these raised signals via selective filter to the feed-in tuning unit. Because of the selective filter, each frequency has its own specific card. This amplifier is push-pull switching amplifier with transformer decoupling. Its output is in square wave, which is feed to transmission filter. Filter's output is in sinusoidal wave, which is feed to TX tuning unit. At filter's output, all higher harmonics are suppressed to avoid interfering of other transmission system in and beside the track. Fluctuations in the operating frequency due to faulty signal generation and processing lower the level at the filter output. Amplifier board for FTG S46 only. This board is suitable for the complete range of frequencies of the FTG S46. Output of transmitter board can be measured on amplifier board as input to amplifier circuit. Measuring socket is provided on this board with LED indication L4.1. Filter board for FTG S46 only. Each frequency requires a special filter card. This filter board must be matched with length of the feed in cable by means of a jumper which is inserted in accordance with the cable compensating resistance. The jumpers are specified in this table. Measuring socket for filter output with LED indication L4 are provided. Receiver 1 board. On the base of multi-stage input filter, there is a specific receiver 1 board for each frequency. The receiver 1 board evaluates the amplitude of the track voltage. When the track is clear, the board passes pulses to the demodulator board and electrically isolated DC voltage to the receiver 2 board. Input filter. The received voltage from track is fed to band pass filter. This band pass filter possesses a broad flat transmission characteristic with steep edges. Transformer coupling at the inputs and outputs of the filter matches voltage and resistance. Input amplifier. For fail-safety purpose, the input amplifier is dual channel design. The two channels are identical in design. The low input voltage is stepped up for the amplitude evaluation. The amplitude of the stepped up input voltage is evaluated by comparing it to a fixed threshold value. If the threshold is exceeded by half wave, one pulse is generated. Gain adjustment. Gain adjustment for received voltage can be done on receiver board after removing from the evaluator. Before removing the board, switch off power supply of evaluator. One tip switch block is provided for this adjustment. When switch is on downside, it is open. Gain adjustment shall be done as per table given. Dip switch position 1 and 10 or 1 and 9 or 1 and 8 or 1 and 7 or 1 and 6 have highest gain. Dip switch position 2 and 10 or 3 and 10 or 2 and 9 or 3 and 9 or 2 and 8 or 3 and 8 or 2 and 7 or 3 and 7 or 2 and 6 have normal gain. Dip switch position 3 and 6 have lowest gain. After commissioning, no adjustment should be done except during monsoon season when the ballast resistance is affected. After adjustment of gain, TSR testing is compulsory. Measuring sockets with LED indications are provided on front panel of this board. Input from site RX tuning unit can be measured in socket E1 and 2. One L5 LED indication for channel number 1, 2 L5 LED indication for channel number 2. Demodulator board. This board consists arrangement to accommodate cooling plugs, quartz oscillators, comparator circuits, 2 outputs to receiver 2 board. This board has 2 channels. Both channels are identical in their dynamic behavior but with an exactly opposite structure. The two channels differ in following aspects. The logical signals are inverse. The counters run counter to each other. The PROMs are inversely programmed. The input signal is conditioned and triggered in reverse directions. The flip-flops are logically inverse in their operation. By this arrangement, 2 out of 2 logic is achieved. The function of the demodulator is to evaluate the bit pattern of the voltage received. The demodulator is activated by receiver 1 after the evaluation of the amplitude of the track voltage. The two serial bit sequences, external from site and internal from code bit plugs, are compared by an EX or exclusive OR gate. If they are the same, the comparator goes high. If they are different, it goes low. This result of comparator is indicated by LED 6. Front panel of this board consists of 2 windows for code bit plugs for each channel. LED indications. One L6 lit proves code bits received are correct for channel 1. 2 L6 lit proves code bits received are correct for channel 2. No measuring socket is provided on this board. Receiver 2 board. Two types of boards are available as below. S25533 B39A3 for standard track circuit. S25533 B34A3 for point track circuit, for center fed track circuit, for crossing track circuit. Receiver 2 board. Basically, this board is divided into 3 different stages: clock pulse amplifier and operation output stage. This board consists 2 identical channels for safety reasons. Final output track relay is driven by each channel. Clock pulse amplifier. For each channel, the AND operation requires a scanning pulse. This is generated on the transmitter board. The clock pulse amplifier amplifies and shapes this signal and converts it from the 5 volt to 12 volt DC. Dynamic and operation for each channel. The receiver 2 board combines the output signals of the receiver 1 board, amplitude evaluation and frequency, and demodulator board bit pattern check. And also chronological sequence of the 2 signals is checked when the track circuit is occupied and when it becomes output stage. This stage is for each channel. This stage consists pulse expander, amplifier, transformer, rectifier. Output voltage is supplied to the tracked relay in relay. This output is indicated by LED 7. Front panel of this board consists of 2 measuring sockets for each channel with LED indication. In measuring socket 111 and 112, output of output stage to track relay 1. This output is indicated by LED 1. In measuring socket number 211 and 212, output of output stage to track relay 2. This output is indicated by LED 2L. Relay board. S25533 B36A3. This board consists of 2 tracked relays, one for each channel. These relays are Siemens K50B type relay with contact configuration 4F/2B. These relays are named as GF1 and GF2. Front contacts of both GF1 and GF2 are wired in series. Back contacts of both GF1 and GF2 are also wired in series. These relays are interface between FTGS and signaling interlocking. These relays are made slow to pick up by 600 milliseconds and also are made slow to drop by 250 milliseconds. For each track circuit, there is a separate power supply unit. S25533 A11A1. It is mounted on rear of the rack. Input to this power supply is 230 volt AC. Outputs are 12 volt DC, 5 volt DC. Separate fuse is provided for each output. 10 ampere fuse for 12 volt DC. 5 ampere fuse for 5 volt DC. Separate output on and output fail indication for each output. Separate measuring sockets for each output. Color code of wires are maintained for each output. Blue 0 volt, white 5 volt DC, red 12 volt DC, black 0 volt, one red indication for input AC voltage. Tuning units are connected near track. The units are selected in accordance with the type of joint and frequencies used. At transmitter end and receiver end, TUs are connected. Tuning unit is used to tune the electrical separation joint to resonance. For each track circuit frequencies, specific type of tuning unit is required. FTG S917 S25533D1 0A, FTG S46 S25533 D1 3A, FTG S46 S25533 D1 4A for center feed in track with equipotential bonding. FTG S917 S25533 D1 1A without terminal bond and with insulation joint. By changing jumpers, we can use tuning unit as TXTU or RXTU. This information is given in installation. Balancing of traction return current in tuned zones, bonds are provided. In the rail signal are sent and received by bonds. S bond is used where both side name FTG SAFTCs are installed. An operational stop of the first or last axle must be prevented within the S bond. If the adjacent track circuits are different, one side FTGS46 and other side FTGS917, asymmetric S bond is used. Terminal bond is used where one side FTGS AFTC and another side conventional track circuit are installed. Terminal bond is used where one side FTGS AFTC and another side axle counter section are installed. Terminal bond is used where two FTGS AFTCs separated by insulated joints are installed. Shunt bond is used where one side FTGS AFTC is installed and another side non-track circuit area exists. Equipotential bonding is used where FTG S46 AFTC is installed with center-fed arrangement. Effective zones of tuned zone. Indoor equipments. FTG S-track circuit racks are available in two types. S25533 G16 A2, S25533 G17 A1, S25533 G16 A2 can accommodate 9 FTG S-track circuits mounting frames. S25533 G17 A1 can accommodate 10 FTG S-track circuits mounting frames. Mounting frames. S25533 C11 A2 FTG S9 17ST, S25533 C10 A2 FTG S9 S217WK, S25533 C10 A2 FTG S917K, S25533 C14 A2 FTG S46 ST, S25533 C14 A2 FTG S46 M. For installation of outdoor SEM2, Chapter 17, Para 70 must be followed. Tuning unit installation. As per frequency plan, prepare table for tuning unit for a yard as shown, then start for installation. For tuning unit type, take the help of manual. Total types available are 1 to 4. For the selection of tuning unit, adjacent track circuit frequency must be considered, especially for S-bond and modified terminal bonds. This restriction is not applied for shunt bond and ordinary terminal bond. Earth connection in tuning unit shall be done as per OEM manual. Transmitter TU connections. Terminal number 11 and 14 for the cable from relay room. Terminal number 9 and 10 for the cable to rails. These connections are done by steel or copper wire. Receiver TU connections. Terminal number 9 and 10 for the cable from rails. Terminal number 15 and 20 for the cable to relay room. Standard looping in tuning unit. For FTG S917 TX, the loop between terminal number 2 and 8, 7 and 8. For the FTG S46 TX, no looping. For FTG S917 RX, the loop between terminal number 2 and 8, 6 and 7, 3 and 11, 4 and 13. For FTG S46 RX, the loop between terminal number 3 and 11, 4 and 13. Standard input voltage from site to RX card is 0.3 volt to 2 volt AC. To maintain these level, do jumpers as below. Voltage adjustment in receiver TU. Jumpers between terminal number 3 and 11, 4 and 13 has low voltage level. Jumpers between terminal number 3 and 12, 4 and 13 has medium voltage level. Jumpers between terminal number 3 and 11, 4 and 12 has high voltage level. Laying of bonds. For laying of bonds follow frequency plan, station working rule, SEM Para 17.5, traction manual, OEM manual. FTGS with bonds at boundaries. Insulated steel bond conforming to standard IS-280 and IS-2266 are used for all type of bonding. The cross section is determined by traction returned current amount. Bond cross section area 1 into 240 mm square, 4 into 240 mm square, 2 into 480 mm square, 1 into 960 mm square. For laying of bonds in the rail web, use one rail fastening clamp per sleeper. Use insulated guide bases. Use of protective tubes and pipes is not permitted. Interconnection concept. An interconnection is any conducting connection that forms a parallel circuit to the earth rail. Following are interconnections: return conductors to substations, track bonds, earthing conductors to metallic bodies, non-insulated OHE mast or signal mast, cable sheets and shields if they are connected to the earthing rail. Limitations of interconnections. FTG S46. Maximum distance between two interconnecting bonding is 80 meter. At substation feed-out points, no interconnections within the track circuit length. From the track bonds, interconnection must be 20 meter away from it. FTG S917, maximum distance between two interconnecting bonding is 80 meter. At substation feed-out points, no interconnections within the track circuit length. From the track bonds, interconnection must be 10 meter away from it. Interconnection inspections must be done within 3 months with PWA and OHE staff. Bond length depends upon type of bond, material of track lead wire, cross-section of bond, single or multiple cable, type of FTGS. Track lead wire steel 25 mm square, maximum length 3 meter. Track lead wire copper 25 mm square, maximum length 15 meter. Cable termination. Indoor cabling. The intermediate distribution rack and the cable termination rack are connected to the FTGS rack using quad cable without armoring. The core pairs for receivers and transmitters must be run in separate cables. Jumpering the transmission and receive lines in the cable termination rack in the distributor racks must be jumpered using standard cores 2 into 0.8 by 1.4 mm. These jumpering must be arranged so that they are not in contact with one another. A distance of 1 cm or 2 cm is required to avoid short circuit of transmission and receiving lines. Earthing. If earth-free installation of the rack is installed, then earth leakage detector is required. Outdoor cabling. Connection in between cable termination rack and track side tuning unit must be done by quad cable with shield 0.9 mm diameter. Separate cable for transmitter and receiver. Parallel connection of cores to increase the cross-section is not permissible. Receivers of different track circuits with the same frequency and same bit pattern must not be run in one receiver cable. Transmitters of different track circuit with the same frequency and same bit pattern must not be run in one transmitter cable. Adjacent sections must not work with the same bit pattern. The same frequency and bit pattern combination must not be repeated in the next 4 adjacent consecutive sections. Fail-safe adjustment. Increase in the sensitivity of the receiver voltage, which is an adjustable parameter, is not permissible on account of safety considerations. The adjustment of the track circuit must be undertaken only under the best ballast conditions. With frequency plan and tuning unit plan for earthing and protective measures is also essential. For fail-safety purpose, the input amplifier is dual-channel design. The two channels are identical in design. The low input voltage is stepped up for the amplitude evaluation. The amplitude of the stepped-up input voltage is evaluated by comparing it to a fixed threshold value. If the threshold is exceeded by half wave, one pulse is generated. Gain adjustment should be within a limit so as receiver voltage should not exceed threshold level. After adjustment of gain in receiver 1 board, TSR testing is compulsory. Parameters. Power supply unit PSU. Input to PSU is equal to AC volts, 110 volt AC plus or minus 15%. Output of PSU is equal to DC volts, 12 volt DC plus or minus 1 volt is equal to DC volts, 5 volt DC plus or minus 0.5 volt. Readings at TX end. Frequency of AFTC equal to measure the frequency. Input of tuning unit is equal to 30 volt AC to 100 volt AC. Terminal number 11 and 14 audio frequency voltage. Output of tuning unit is equal to measure the voltage AC, terminal number 9 and 10. Voltage across the rails. Measure the voltage AC. Reading at RX end. Voltage across the rails equal to measure the voltage AC. Input to tuning unit is equal to measure the voltage AC. RX end terminal number 9 and 10. Output of tuning unit is equal to 0.3 to 2 voltage AC. RX end terminal number 15 and 20. Do's and don'ts. Do's. For installation, follow OEM manual. For traction bonding, follow traction manual. With frequency plan and tuning unit plan for earthing and protective measures is also essential. Directionality test for S-bond is must. After adjustment of gain in receiver 1 board, do TSR testing. Do the adjustment of track circuit in best ballast condition. Power supply shall be taken from IPS. Do inspection of interconnection regularly. Do TSR test after replacement of tuning unit. Check all plugs carefully. Don'ts. Don't pull or place any board with power on condition. Don't touch the semiconductors, ICs of the boards with bare fingers as they are static sensitive components. Don't repeat the same frequency and bit pattern combination in the next 4 adjacent consecutive sections. Don't make parallel connection of cores to increase the cross section. Don't make any unauthorized modifications in FTGS.